Okay, in this video, we are going to use what we know about angle relationships and their measures, if they're supposed to be supplementary or congruent, to determine the measure of a missing angle in parallel lines cut by a transversal. So go ahead real quick and take a moment, maybe pause the video and try to test yourself to see if you remember what the parallel lines and transversal are. If you'd like, you can wait a second so I can show you how to do the first one. What I mean is highlight the two parallel lines. That way you can easily see the parallel lines and the transversal. So hopefully you're pausing the video and trying this on your own. That's just the top four. Those are all the transversals. Now I'm highlighting all of the parallel lines. That was really bad highlighting. Okay, and we're going to do that 6 more times, it looks like. Now I'm going to highlight the parallel lines first. There's the two parallel lines. Alright, and now I'm going to trace all of the transversals again. Transversal cuts through the two parallel lines. Transversal cutting through two parallel lines. Okay. So before we get started on the angle relationships, and even the missing measures, let's just review a few things while I refocus the camera here. Okay, there we go. That's much better. I hope it wasn't too fuzzy for too long. Okay, what I notice here is that I've got a right angle, and I know that right angles are 90 degrees. Okay, so since 90 degrees makes up the right angle, I know that A and B together make up that 90 degree angle. A and B together, so I'm adding, make up the 90 degrees. So I know that A plus B should equal 90. I believe we've done this in class, and I just want to, we did do this in class, and I want to show you guys on the video just because I think it's really cool. Okay, so here I've got a triangle. That's a little easier for you to see. I'm going to just color in the angles of the triangle real quick. And you guys already know that triangles make up 180 degrees. You know that from other past years. Okay, so I've got a triangle with the angles all colored in. If I tear off those angles, oops, and have them on the side that I colored. Okay, now I'm going to put the colored sides together. Like that. And got one more. Okay, so when I do this, it creates a half circle. So a half circle has these three angles, or a straight line. It's not sticking. It makes a straight line right here. So a straight line then can be made by the three angles in a triangle, which makes 180 degrees. So a straight line then is 180 degrees. Same thing for half a circle. That would be 180 degrees inside. That means, though, if I had a second triangle and I took its angles, it would make the other side of that line, or the other side of that half circle, which shows us that we have two sets of the 180 in a circle. So one circle then is 360 degrees, right? Okay. I just like doing that because it's fun to see math visually work in front of your face. All of that just to say that in the second box there, we've got angle F and angle G. Angle F and angle G work together and they create a straight line. So I know that all together that's 180 degrees. And it's made by combining F and, so adding G. So F plus G is 180. And just a little bit of vocab. We've talked about this word a whole ton this year. Congruent means equal in measure. Means equal. All right. Okay, so let's look at the first set of angles here. They've got X here, and they've labeled X as 110 degrees. And then we have Y labeled right there. Just Y. Not Y degrees, sorry. Okay. It's 110 degrees. We want to know two things. We want to know the measure of Y, and we also want to know the relationship between X and Y. So the relationship is going to be those vocabulary words that you guys are committing to memory and love super a lot. So I see that X and Y are on two different parallel lines. Since they are on two different parallel lines, I know I'm not dealing with vertical angles or adjacent angles. Now 110 is on the outside of the box and Y is on the inside of the box. So I'm not dealing with exteriors and I'm not dealing with interiors, which means those angles are corresponding. And we can check that because if this is my box, right, X is on the top and on the left side of the parallel line. On the other parallel line, Y is also on the top of it and on the left side of the transversal. So they're in the exact same spot or matching spot. So X and Y then are corresponding. Corresponding angles are equal to each other or congruent. So since they're corresponding, I know that X is equal to Y because they're congruent. So if X is 110 degrees, that means Y is also 110 degrees. Looking at the example to the left of that, sorry, to the right of that, I don't know left and right today. We've got X and Y stacked kind of on top of each other in a line, a vertical line maybe. Now we are on one of the one of the parallel lines. We're not dealing with the bottom parallel line here. If I'm on one parallel line, that means my options are adjacent or vertical. I notice that this is an X, and X and Y are across each other in an X shape, which would mean that those angles are vertical. I spelled vertical wrong. Vertical. Okay. Now vertical angles, we learned, were congruent. Since vertical angles are congruent, that means X and Y have to be equal. Because I had vertical angles, I know that they're congruent, which means X and Y are equal. So if X is 130 degrees, that means Y is also 130 degrees. I think this is interesting to kind of look at. I like this example a lot because the number is kind of easy. So I'm going to just draw that example real quick. Right here, there's T followed by two parallel lines. Sorry, here's T. I'm going to label T down here. There's T followed by two parallel lines. I'll call them R and S. Okay. And this is X labeled at 130, Y And I can prove to you now that y is 130 without having to use my vocabulary sheet, actually. Because I know that straight lines make 180 degrees. So x plus this piece should make 180 degrees. Oops, you guys can't see that on the video. That should make 180 degrees. So 180 is 130 from x plus the thing I didn't know. What number can I add to 130 to get 180? That would be 50. So now I know that this angle is 50. Now I know that's not angle y. I get it. That's not angle y. So how can I prove to you that I know angle y is 130 degrees? Well, that's simply because I know. It's fine. Yeah, that's because I know that this angle and this angle make a straight line on R. So y, angle y plus 50 should be 180 as well. If I wanted to get y all by itself, I could just subtract 50 from both sides. The 50s make 0 on the left, leaving us with y equals 180 minus 50 is 130. So there I've proven to you, without having to use my cheat sheet of which things are congruent and which things are supplementary, that y is 130 degrees. Now, granted, that was 2 steps of math, so it's easier if you memorize your vocabulary like a perfect 8th grader would. I'm going to try and erase that a little bit, and we'll get back here. Okay. The next set of angles I've got. Here's my parallel lines. X and Y are both inside of the box, so I know I'm dealing with some sort of interior angles. My options for interior are same side interior or alternate interior. Same side and alternate mean of the transversal, in relation to the transversal. So here's the transversal, that red line in the middle. X is on the right side of it and Y is on the left side of it. Since they're on opposite sides, I know that this is same side. Same side. They're on opposite sides of the I said same side. X and Y are on opposite sides, so this is alternate interior angles. I don't know why I'm not writing on the line. Alternate interior angles. So Y would make 180 degrees with this. Okay. It's a lot easier, I promise, if you memorize your vocabulary. Alternate interior angles are equal. Remember, alternate angles are equal. Okay, so that means that 36 is X, that's what they told us. Since alternate angles are equal, Y is also 36 degrees. You can kind of see that Y is a small angle, acute, and so is X. X is also a small acute angle. Because the relationship was alternate interior between X and Y, I know that those angles were congruent. So X and Y were equal to each other. Right, looking at the next example on the right, so second row on the right. First, let's look at the relationship between X and Y. I'll close the box with my parallel lines. X and Y are both on the outside, so I know I'm dealing with some sort of exterior angles. Our options are same side of the transversal, exterior, or alternate sides of the transversal, exterior. X is on the left and bottom of the red line. Y is on the right side and kind of on the top of the red line. So they're opposite sides, which means their relationship between X and Y, the relation is alternate exterior angles. Now, because they're alternate exterior, any kind of alternate relationship has congruent angles. Since those are congruent angles, I know that x has to equal y. So if x is 52, y is also 52. And again, you can kind of see that x is a small angle and y is also a small angle. Now looking at the third row on the left side, if I close the box between my two parallel lines, x and y are on the inside. So I know I'm working with interior angles. I just have to decide if they're co-interior on the same side of the transversal inside the box, or alternate interior, opposite sides of the transversal inside the box. This is the transversal. X is underneath that on the left side of it, and y is also underneath it on the left side of it. Since they're both underneath on the left-ish of the red transversal, I know I'm dealing with same side interior angles, or co-interior angles. Now, same side angles, whether interior or exterior, are supplementary. Same side, supplementary. So, because I know they're supplementary, I know that x plus y has to equal 180. X is 135 plus y should equal 180. So we're going to have to look at that vocabulary again, or equations again. We've got 135 plus y should be 180. To get y all by itself, we need to undo the 135 from both sides. The 135s make 0, a 0 pair on the left side, leaving us with just y equal to 180 minus 135 is 45 degrees. I know this is degrees because y is measuring an angle, and we measure angles with degrees. So y is 45 degrees. Last example in the third row, in the middle row, right example. Closing the box, x and y are both inside of the box. I might be dealing with interior. The next thing I notice, though, is I'm not even using anything from this parallel line. So I'm only using one parallel line. My options are vertical or beside each other, adjacent. If I create the x and y are right here and here, not vertically, not across in the x shape. Instead, they actually share one of the sides that I outlined. Since they share a side I outlined, I know their relationship is adjacent. Same side and adjacent things are supplementary. Since this is supplementary, I know that my two angles, x and y, have to add together, that's why I have the plus sign, to equal 180 degrees. We already know that x is 75 plus y is 180. To get y by itself, you just take away the 75 from both sides. That leaves a 0 pair on the left. So only y remains on the left side. Now 180 minus 75 is 105. You couldn't see it. Is 105. Okay. So y then is 105 degrees. The next four examples, the last four examples on the page, correspond with the three problems on the back of the homework. So these problems kind of correspond with the first side of your homework, and the last four problems correspond with the back side of your homework. Okay. So in these last four problems, they actually give us one angle measure, and then they need us to find all of the other missing angles. This seems hard, but hopefully I've shown you in class My brain is a little scattered in this video, so I'm not going to show you in this video. I will make a separate video for it, proving and explaining why I know that I only have to do one math problem, and then I'll be able to tell you all of the angles here. The one math problem I have to do is I have to figure out, here I have a straight line. I already know x is 122. This is 122 degrees. I have a straight line, which means this missing piece plus x, which is 122, should create a straight line. And we already know straight lines make 180 degrees. So the one math problem I need to do is 180 is 122 plus something I don't know. To get the something I don't know by itself, I just subtract 122 from 180. So now I have the something I don't know is 180 minus 22, or 63 degrees. So this piece here is 63 degrees. When I've got the transversal, anything that is vertical with an angle, I know that those are equal. And that's really easy to see. If I have an obtuse angle, it's going to match the other obtuse angle. Vertical angles are congruent or the same, so I know that this piece here is 122 degrees. 63 is vertical with this piece here, so this is 63 degrees. So how in the heck do I find any angles over here? Remember, if I have things in matching spots, corresponding angles, if it's the exact same angle just on a different side of the line, then they're going to have the exact same measure as well. So on the top left piece of the other parallel line, top left was 63 degrees. Top right was 122 degrees. The bottom left was 122 degrees. Or you can say vertical angles are congruent. And the last piece there is 63 degrees. Again, they're vertical. This 63 is vertical from that 63, so I know they have to be the same. Or you can say this 63 is corresponding with this original 63 we found. So we only had to do one math problem, and we figured out all of the angles. That was if I was given one of the angle measures. Okay. Next one off to the left of that, they've given me that this tiny angle 63, or x, is 63 degrees, and I need to find all the missing ones. What we saw is that we're using the exact same angle measures, and we're only using two different numbers. So all of my tiny angles, my acute angles, are going to match that 63 degrees. We know that because on the bottom parallel line, these 63s are vertical, so that I know they have to be the same. And then from the top parallel line, I can say they're corresponding to the other parallel line I've got, so I know that those are the same as well. Now the other angles are obtuse. I know they're not 63 degrees, but the 63 and the big obtuse missing angle, so plus the big obtuse missing angle, make a straight line, which is 180 degrees. To get the question mark by itself, you would just subtract 63 degrees from both sides. Okay, so now we have the missing piece is 180 minus 63, which is 127. On the previous example, I had 63 degrees. I believe I meant 68 degrees. Yeah, because 8 would make... Sorry, I meant 78 degrees. Those should all say 78. I'm so sorry. Okay, so 63 over here, so we took 63 away from both sides, giving us that the question mark was 127 degrees. Let me check my math there again. That would give me 130, plus that is 190, so this is actually 117 degrees. 120. That's better. Okay. My life is making a little more sense now. So this obtuse angle is 117 degrees. This obtuse angle is vertical from that obtuse angle. I know they have the same measure. These two obtuse angles are corresponding with those two obtuse angles. So those are also 117 degrees. Okay. As we've seen before, we are given an angle, so I know it's 28 degrees here for x. Anything vertical to it is the same measure, congruent. These two vertical angles, I know they're congruent because they're vertical. Now these two vertical angles correspond with the acute vertical angles on the other line, so those are also 28 degrees. Now to find the missing piece, I'm going to take the 28 and the missing piece to make a whole straight line. So 28 plus a missing piece gives me an entire straight line, which is 180 degrees. To get the missing piece by itself, take away 28 from both sides. We're left with a 0 pair and the missing piece on the left side. That tells us that we've got 152 on the right side. So the missing piece is 152 degrees. That makes sense because this is obtuse. This is really big, and 152 is also bigger than 90. Okay. Well, if this is 152, anything vertical to it is 152. By vertical, I mean diagonally across and then x. So these vertical angles correspond with these vertical angles, so these are also 152 degrees. I encourage you to pause the video and try to see if you can do this one on your own. I'll start us off with x is 52 degrees. Anything vertical to x is going to have the same measure because those vertical angles are congruent. So this is 52 degrees there. Corresponding angles are congruent, so this piece and this piece correspond with this piece and this piece, which means those are also 52 degrees. Now to find the missing side, the big obtuse angle, I know that the big obtuse angle makes a straight line with 52. So 52 plus the missing piece will make 180 degrees. To get the missing piece by itself, we take away 52 from both sides. That leaves us with a 0 pair and the missing piece on the left side of the equation. On the right side of the equation, 180 minus 52 is 128. So the obtuse angle that I solved for right here is 128 degrees. It's got a vertical across the x pattern, and it does look really vertical actually here. It's 128 degrees as well, because vertical angles are congruent. Now corresponding angles are also congruent, so I can take these 128s and put them here as well, correctly label the measures of those angles. Not my best 28 minutes of talking. I hope this gets the point across of what we were trying to do today, just using a given measure of an angle in parallel lines cut by a transversal to find the other missing angles. The homework for this should be page 31 if you're in the school year 2021 to 2022. The homework for this is page 32. I've talked about it in class. If you have questions about the notes or the homework, please feel free to send me a Schoology message, an email, or get in contact with me in some form or fashion. My contact information is all over Schoology in the class app and other available resources to you.